Hello everyone, this is Sudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. Today I'm going to talk on a topic of electrical circuit and network. So the topic is very important and very informative topic, which will help all the students to analyze different types of circuits. There is a lesson plan of the subject. So lesson plan is given here. Now today's topic of discussion, so total 6 topics I'm going to discuss for this particular lecture. First one is power factor, then active power, apparent power, reactive power, power triangle, and complex power. So these are the main topics today I'm going to talk on. So the first topic which I'm going to discuss, that is the power factor. So before talking about power factor, all need to understand about uh, the types of power which is available in electrical engineering. So we know that there are 3 types of power in electrical engineering. One is active power, second one is reactive power, and third one is apparent power. So here, active power, the first one is active power, represented by kilowatt. The second one is reactive power, that is kVAR. And the third one is apparent power, that is kVA, kilovolt ampere. So now let me talk about the beer analogy. So what is beer analogy? This analogy will help us to understand these 3 types of power, and it will be easier for us to understand that what is actually the power factor. So here in the first part, if you follow, you can find that the beer is active power. Okay, and I already mentioned that active power is kilowatt. The useful power or the liquid beer is the energy that is doing work. This is the part you want. So useful power means this part of the figure. This is the useful power. That means you can say this part is actually the useful part, the liquid beer, which is available with this figure. The useful power or the liquid beer is the energy that is doing work. So this part is actually doing work in the system. So active power is actually doing work in the system. This is the part we basically want. Now if you search, if you find, if you search, you will get that some part of the beer, if you take it from a bottle to a glass, then some part of the beer will be a foam, the upper part of the beer. So this foam is acting as a reactive power. Okay, so the liquid beer is the active power or the real power, and the foam is the reactive power. The foam is wasted power or lost power. So this foam is wasted or lost power, you can say wasted power or lost power. It is the energy being produced that isn't doing any work. Fine. So this actually not doing any work. It's the energy being produced that doing isn't doing any work, such as the production of heat or vibration. So in our system, sometimes some temperature, some heat produced, some vibration produced, but that is actually the wastage of the system. That is actually the losses of the system. So this part is actually the reactive power. And you can say that it is one of the part of the wasted power or lost power. Now the MOG, the whole MOG, the total MOG from the upper part to the lower part, the whole MOG is apparent power. The MOG is the demand power. The total demand power is the MOG, or you can say the total demand power is the summation of the useful power and the wasted power. That is the total demand power. The MOG is actually the summation of the foam and the beer, liquid beer. So the MOG is apparent power, which is represented by kVA. Here, the MOG is the demand power or the power being delivered by the utility. So it's a very famous example to realize, to understand about three types of power from our system. So with the help of this example, we can understand that what is the apparent power or the demand power, what is the wasted power or the reactive power, and what is the useful power and the active power of a system. So from this concept, now we can develop the equation of the power factor. So here, first try to understand how to calculate power factor. To calculate power factor, you need a power quality analyzer or power analyzer that measures both working power and apparent power. And to calculate the ratio of kilowatt by kVA, kilovolt ampere. So this part we have to understand that we need the power quality analyzer or power analyzer that measures both working power, and we already know that what is the working power. Active power is the working power, that is the unit of the working power is kilowatt. This is the unit of the working power. Now, and the apparent power is the demand power, the total power of the system. So we need these two, the working power and the apparent power kVA, and to calculate the ratio of kilowatt by kVA. So in this way we can calculate the power factor very easily and this process is really very easy process. If you have both the values available, you can easily find the value of the power factor. Now the power factor formula can be expressed in other ways. That power factor equals to true power divided by apparent power, or power factor. So we already talked on this, that it is the true power divided by apparent power, kilowatt divided by kVA, or power factor equals to W by VA. So if we kilowatt, look, what was the equation? It was kilowatt divided by kVA. So it's ratio, power factor, active power, apparent power. So if we omit K and K, then what will happen? W by VA. This part will be there. So where watts measure useful power, while VA measures supplied power. So what is actually measuring the useful power, and this is measuring the useful power, and the VA that is the volt ampere, is measures supplied power. The ratio of these two is essentially useful power to supplied power. So these are the method, these are the formula we can understand or we can calculate the power factor. Now, so we can explain it in some other way that we know that power factor is also represented with cos theta, or you can say sometimes it's cos phi. So cos phi is basically the angle between the voltage and current, the cosine angle between the voltage and current. So this is the phi. Sometimes it is also, the equation is also called the cosine angle between the voltage and current, sometimes called the power factor. This is one of the definition of power factor, the angle, cosine angle between the voltage and power. Now, if we want to understand, we can relate. So what is what? What is the real power? And we know that the real power equation is VI cos phi or cos theta. And what is VA? So VA means voltage into current, VI. This one, II. So what will be there? Only cos theta. And we know that cos theta is the power factor. So in this way, we can also define the power factor. It's the angle between the cosine angle between the voltage and current, and also it is the ratio of real power to apparent power. Now, with the help of the diagram demonstration, power factor compares the real power being consumed to the apparent power or demand of the load. The power available to perform work is called real power. You can avoid power factor penalties by correcting the power factor. So here in this diagram, if you follow, you can find that this is the reactive power, this is the true power. Now, the summation of these two, the vector summation of these two is the apparent power. So in this way, we can, so if it is the phi, the angle phi, then the ratio of true power and apparent power is called the power factor. In this way, we can also find or understand the power factor. Now, come to the next point, or the basic point, that is the active power. We already talked about active power to understand the BR analogy, but here we'll try to clear concept more. So the active power definition is very easy definition. The power which is actually consumed or utilized in an AC circuit is called true power or active power or real power. So it has three names: true power, active power, and real power. So this real power or active power is basically the power which is actually consumed or utilized in an AC circuit. Okay, so for that reason, it has some existence, it has some activity, it has some reality. So for that reason, this power is called the active power or true power or real power. So how it is measured? You know that it is measured by kilowatt or megawatt. So this active power is measured by kilowatt or sometime in megawatt. It is the actual outcomes of electrical systems which runs the electric circuits or load. That means the electrical system, all the machines and everything is running actually with the help of this active power. So the active power is the most important part, but all are related. Something, all three types of power is related with each other, but to run all the machineries, all the electrical systems and all the electrical circuits, the role of this active power is the best role. Now, reactive. The first one was active power and second one is reactive power. Look here. So active power, you know that it is represented with P, the active power, and you know that it is VI cos phi, where V is the voltage, I is the angle, and cos phi is the cosine angle between the voltage and current. So this is the equation of active power. We'll apply this equation to solve different types of problem of this active reactive power and the power factors. Now let's talk on this reactive power. The power which flows back and forth, that means, so in which direction this type of power flows back and forth. That means it moves in both the directions in the circuit or reacts upon itself. It's called reactive power. So this is one of the most important definition. Maybe the same question will be asked to you at the time of your job interview or different places. So what is reactive power? So you need to remember like this: the power which flows back and forth, that means it moves in both the direction in the electrical or reacts upon itself, is called reactive power. The reactive power is measured in, you all know that how it is measured: kilovolt ampere reactive, kVAR, kilovolt ampere reactive, or MVAR, megavolt ampere reactive. So this is the, this way we can define reactive power, and it's the unit of the reactive power. Now the third one is the apparent power. Definition, if you consider the definition, the product of root mean square, RMS. You all know that what is RMS value. I already discussed it in my previous lecture. So if you have confusion, you can follow that. The product of root mean square, RMS value of voltage and current. Root mean square, that is the RMS value of voltage and current, is known as apparent power. Product means the multiplication. That means the V and I, if we multiply this to V into I, that is the apparent power. The product of root mean square, RMS values of voltage and current, is known the apparent power. This power is measured by kVA or MVA. Okay, so this power, how the apparent power is measured? The apparent power is measured with the help of kVA, kilovolt ampere, or megavolt ampere. So volt ampere, VA, sometime in VA, sometime in kVA, sometime in MVA. So this is the measure of the apparent power. Now we already talked about the equations of active power. The active power is represented with P, the reactive power is represented with Q, and the apparent power is represented with S. And you know that I already talked that P equals to VI cos phi. So VI cos phi. VI is the voltage, I is the current phasor, voltage phasor and current phasor, and the angle between these two phasors, cosine angle. The reactive power is the summation, multiplication of V and I, and the sine angle between the voltage and current, sine. So Q equals to VI sine phi, and the apparent power S. Apparent power is represented with S, and that is equals to only the multiplication of voltage and current. So why and how it is happening? Look, you already, you know that if we draw a triangle, okay, suppose this is the triangle, and if it is the angle phi, or if it is the angle phi, then what will happen? This will be S. If we consider which one will be V, and one will be active power, one will be reactive power. So if this is the apparent power. So apparent power, as per the Pythagoras, this should be equals to root over active power square plus reactive power square. Okay, so you know this is v square I square into, if we sum v square I square cos square theta, v square I square sin square theta, so this is sin square theta, sorry, phi plus cos square phi. Okay, so if we take it from the root, then square square will vanish, so only vi will be there, because sin square theta plus cos square theta will be equals to 1. So the value of this power is equals to vi. So in this way we can prove, using active power and reactive power, that the apparent power is nothing but the multiplication of V, voltage and current. Okay, so these are the three formula. Please try to remember these three. It will help you a lot to solve the problem of electrical engineering about the power analysis. Now the power triangle, I already talked on this, that the power triangle is the representation of the right angle triangle showing the relation between active power, reactive power and apparent power. So here this figure consider that the AO or OA is the true power, that is represented with kilowatt, and the equation is P equals to VI cos phi. And the reactive power Q equals to VI sin phi, and the volt ampere reactive, and third one is apparent power is equals to VI, that is volt ampere. So if you follow, you can find that the OB is equals to, OB is the summation of OA plus AB. So I just, in the last slide, I just proved that how S equals to VI. So if we draw a triangle like this, so that will be the, so that is called the power triangle of the three types of power, where one power is active power, another one is reactive power, and the third one is apparent power. So this is the representation of power triangle. Now the question is, what is complex power? Complex power is represented with S. S equals to P plus JQ. So what is P, what is J, what is Q? You all know. P is the active power, Q is the reactive power. So the term, new term is come, that is the complex. For that reason J is coming. You all know that J equals to root over minus 1. What is J? J equals to root over minus 1. Or sometime we can represent with VI star. Okay. So the complex sum of real power and reactive power is known as complex power. So that is represented with this equation is equals to P plus JQ. That is the complex sum, P plus JQ, complex sum of real power and reactive power. Q is known as complex power, which can be expressed like S equals to P plus JQ. Already expressed and measured in terms of volt amperes, reactive, K VAR. Okay, measure. This is the measure of the reactive power. It may also expressed in S equals to VI star, where I star is the conjugate of the complex current I. So this current I flows through a reactive load Z caused by the voltage. So we can represent the complex power with S equals to P plus JQ or S equals to VI star, where I star is the conjugate of complex current I. So here, if you follow this one, same Then the complex power formulation. Now let me show you complex power in capacitive load. Z equals to R minus JXC. For capacitive load, it is Z equals to R minus JXC. You already proved this. And I equals to IP plus IJQ. IP is real power current plus J into reactive power current. So cos phi equals to R divided by Z when it is leading. So I star is IP minus, so S equals to VI, it is S equals to VI star. We consider I equals to this one. So what will be I star? IP minus JIQ. Very easy. So the value of S will be equals to P minus JQ when it is capacitive load. Fine. For capacitive load, the value of the impedance Z equals to R minus JXC. Now, if it is inductive load, then what will happen? For inductive load, complex power in inductive loads, Z equals to, in the last part it was Z equals to R minus JXC, but here it is Z equals to R plus JXL. So current was positive for capacitive power, but here it is negative, IP minus JIQ. And the cos phi equals to R minus Z for lagging. The last one was leading and this one is lagging. So if I equals to IP minus JIQ, so what will be the complex conjugate of I star? That will be IP plus JIQ, and the value of S will be equals to P plus JQ. So for inductive load, S equals to P plus JQ. For capacitive load, S equals to P minus JQ. So these are the calculation, these are the value we have to remember. Now, where Z equals to impedance, in the last slide we already explained, where R equals to the Z equals to impedance, R equals to the resistance, XL equals to inductive reactance, S equals to capacitive reactance, cos theta equals to power factor, P equals to active power, S equals to apparent power, and Q equals to reactive power. So the meaning of all the terms is clear here. In my previous lecture, I already defined you that what is inductive reactance, what is capacitive reactance, how these things are calculated. Please go through the lecture if you want to clear your concept more. If you have any doubt, please follow that lectures. It will be clear to all of you. Now the complex power can also be expressed by the following formula. There is another formula to express the complex power, S. That is root over P square plus Q square. This is the magnitude. And the angle is tan inverse Q by P. So with this formula also we can express or we can represent the complex power. So where is equals to root over P square plus Q square, angle tan inverse Q by P. Now these are the reference I used to prepare this PowerPoint presentation. These are the links. And finally, thanks for watching the lecture. If you have any doubt, please contact with me. Thank you all.